Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics and the past paper questions on the topic of algebra, the question that came in section 2 of paper 2. We'll be looking at the solutions for the years May 2019 until the present. Feel free to like the video and add any comments down below, so we can help create other videos for you to assist in whatever areas that you're struggling with. Don't forget to look at the description down below, where we have outlined the entire syllabus and the order we suggest that you go through it to get a better grasp of this entire subject. Let's recap the 10 major topics in CSEC Mathematics, and this video deals with topic number 6, algebra, and topic number 7, relations, functions, and graphs. Both of these topics come as individual questions in section 1 of the paper and as one combined question in section 2 of the paper, which is what this video is about. This combined question is worth 12 marks out of 100 in paper 2. Some of the major topics that are tested in this includes quadratic equations, simultaneous equations, linear programming, speed-time graphs. May 2019, number 8a, two functions f and g are defined by f of x equals to 9 over 2x plus 1, g of x equal to x minus 3. Part 1. State the value of x that cannot be in the domain of f. In the domain of f means that that function cannot take that x value. So if we look at that function f of x, we can see that it's a fraction. For it not to be able to have a value, the denominator has to be equal to 0. Then f of x will be undefined. Let's recall the denominator is 2x plus 1, and let's make that equal to 0. So 2x is equal to minus 1. So x is equal to minus a half. As such, when x is equal to minus a half, that cannot be in the domain. Part 2. Find, in its simplest form, expressions for part A, f g of x. So if we're looking at this composite function, the first function we should look at is the function closest to x, which is g of x. So let's rewrite that. G of x is equal to x minus 3. So now we can replace in the composite function g of x by x minus 3. So we can write f of x minus 3. Now let's recall the function f of x is equal to 9 over 2x plus 1. And instead of having x, we're replacing it by x minus 3. So f of x minus 3 is equal to 9 over 2 by x minus 3 plus 1. And the denominator works out to be 2 times x is 2x, minus 2 3s are 6, plus 1 is minus 5. So f g of x is equal to 9 over 2x minus 5. Part B. Find in its simplest form f inverse x. So f of x is equal to 9 over 2x plus 1. So we'll try to make x the subject of the formula. So we have 2x plus 1 as the denominator on the right hand side. Let's bring it across. So we're going to get 2x plus 1 times f of x is equal to 9. And let's expand 2x times f of x plus 1 times f of x is equal to 9. So if we want x alone on the left hand side because we want to transpose, then let's move the f of x on the right. So we're going to get 2x by f of x is equal to minus f of x plus 9. And we want x alone on the left hand side, so we could carry across the 2f of x. So it's going to give us minus f of x plus 9 all over 2f of x. And let's rewrite it in the form that we want. Let's replace x by f inverse x. So f inverse x is equal to minus x plus 9 over 2x. May 2019, number 8b. The diagram shows two rectangles ABCD, that's the larger rectangle, and GFED, the smaller rectangle, which is shaded. ABCD has an area of 44 centimeters squared. GFED has sides 4 centimeters and 2 centimeters. AG is equal to EC, which is equal to 3x centimeters. Part 1. By writing an expression for the area of rectangle ABCD, show that x squared plus 2x minus 4 is equal to 0. Let's recall area of a rectangle will be length times breadth, which in this case works out to be 44. And let's use the length AD to be 3x plus 4 times the breadth, which is 3x plus 2, will give us 44. And if we expand the brackets on the left hand side, we can multiply the first term by the first term. 3x by 3x is 9x squared. We can multiply the first term by the last term. 3x times 2 give us plus 6x. And then the inner term by the inner term, plus 4 times 3x will give us plus 12x. And the last term by the last term, plus 4 times plus 2 is plus 8, which is equal to 44. And we can simplify that and bring the 44 across onto the left hand side, so we leave the right hand side as 0, because we're trying to show that it looks like that form above, where the right hand side was 0. So that's going to give us 9x squared plus 6x plus 12x is 18x plus 8 minus 44. And we can simplify further. 9x squared plus 18x plus 8 minus 44 is minus 36 is equal to 0. And if we look through that, we can see that we can divide throughout by 9. So that gives us x squared plus 2x minus 4 is equal to 0. And we have completed the proof. Part 2. Calculate at 3 decimal places the value of x. Now we have a quadratic equation. 0 is equal to 1x squared plus 2x minus 4. And we can use the quadratic formula to solve it. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Where we have a as 1 in maroon, we have b as plus 2 in green, and we have c as minus 4 in purple. So let's substitute. Minus plus 2 plus or minus the square root of plus 2 squared minus 4 times 1 times minus 4 all over 2 times 1. And that will simplify to minus 2 plus or minus 2 squared, 2 2s are 4, minus 4 times minus 4 is plus 16. So 4 plus 16 is square root of 20. So minus 2 plus or minus the square root of 20 all over 2. So either x will be equal to minus 2 plus the square root of 20 over 4, which gives us x is equal to 1.236, because we want our answer to 3 decimal places, or x is equal to minus 2 minus the square root of 20 over 2, which works out to be minus 3.236. And obviously, if we're measuring a length, then the length will be positive. So x will be 1.236 centimeters. Part 3. Calculate the perimeter of the unshaded region. So if we look at the unshaded region, which looks like an L, then the perimeter will be AB plus BC plus CE plus EF plus FG plus GA, which carries us back to A. And that is 5.708 plus 7.708. Remember, x is 1.236, so we're substituting. Plus CE is 3x, which is 3.708, plus 4 plus 2 plus 3.708, which works out to be 26.832 centimeters. May 2021, number 8A. Marla buys 2 types of mobile phones, B-Flow and C-Flex, from a company to retail. One B-Flow mobile phone costs $60, while one C-Flex costs $80. She buys X number of B-Flow phones and Y number of C-Flex phones. Part 1. Marla must not spend more than $1,200. Write an inequality to represent this information. Since B-Flow phones cost $60 and she buys X number of them, then the total cost she will be spending on buying B-Flow phones will be 60 times X. And similarly, it will be 80 times Y, because there are Y number of phones that she bought at $80 each. And if we add up 60X plus 80Y, it must not be more than $1,200. So it must be less than or equal to $1,200. Part 2. The number of B-Flow phones must be greater than or equal to the number of C-Flex phones. Write an inequality in X and Y to show this information. The number of B-Flow phones will be X is greater than or equal to Y. Part 3. Represent the 2 inequalities on the grid shown. Label as R the region which satisfies both inequalities. So if we bring up our grid and let's look at our information. 60x plus 80y is less than or equal to 1200. Let's rearrange it so it will look like the general equation of a straight line graph. So let's make y the subject of the formula. Let's carry the 60x across. We're going to get 80y is less than or equal to minus 60x plus 1200. So y is less than or equal to divide by 80. So it will be 60 divided by 80 minus 0.75x plus 15. This means for a straight line graph that we're going to draw, let's consider y equal to minus 0.75x plus 15. That means that graph is cutting the y-axis at 15, and when y is 0, x is 20. So we can draw a red line as it's going downwards because it's a negative gradient, and it's equal to that line or less than that line. So let's bring up a red arrow to show that it's below that line will be the region of the inequality that we're speaking about in part 1. For the second inequality, let's draw the line x equal to y, and that is a straight line graph passing through the origin, and when x is 10, y is 10, and when x is 15, y is 15. So as we draw this line, that is the line x equal to y. X is also more than y, or we can say y is less than x. So that means the region below that black line. So if we're going to represent the two inequalities, what region that is, that will be that blue triangle that we're bringing up, and it's labeled R to show the region. Part 4. The total number of mobile phones is represented by x plus y. According to the graph, what is the largest possible value of x plus y? If we're considering the maximum minimum values in linear programming, what we're really looking at will be the points of intersection of this region. So let's bring up points here at 0, 0, and the other one at 20, 0, and the one up on top. And which one will give us the maximum value when x is 20 and y is 0. So 20 plus 0 is 20. May 2021, number 8b. The table below shows pairs of values for the function y is equal to x squared plus x minus 4. And if we look at our table, we're given values of x from minus 4 to 3, those 8 values, and we have the 8y values to go with them. So we have 8 ordered pairs. On the graph provided, plot the remaining 4 points and draw the graph of the function y is equal to x squared plus x minus 4 for the region from minus 4 is less than or equal to x, which is less than or equal to 3. So they gave us 4 points, and let's bring up the other 4 points, where when x is 0, y is minus 4, when x is 1, y is minus 2, when x is 2, y is equal to 2, and when x is equal to 3, y is equal to 8. So let's complete the curve, and we can clearly see it's a quadratic equation, a parabola, with a minimum point. Write down the maximum or minimum value of the function. So we can see that there's a minimum point there, and let's bring up that point, the lowest point on the curve. And what do we know? We know at that point x is equal to minus 0.5 and y is equal to minus 4.25. Last part of the question, part 3. Using a ruler, draw the axis of symmetry on the graph. So the axis of symmetry, or the line of symmetry, or the mirror line will be the line in which the graph can be folded equally down the center. So that will be, let's break it up in red, the line x is equal to minus 0.5. May 2022, number 8a. The rental company has X cars and Y vans. The company has at least 8 vehicles altogether. The number of minivans is less than or equal to the number of cars. The number of cars is no more than 9. Part A. Write down 3 inequalities in terms of x and or y other than x is greater than or equal to 0 and y is greater than or equal to 0 to represent this information. So let's look at the first sentence that gives us inequality information. The company has at least 8 vehicles altogether. That means if we add up the number of cars x plus y, it will be equal to or greater than 8. For the second information, let's look at the next line. The number of minivans is less than or equal to the number of cars. And the number of minivans is represented by the letter y. So y is less than or equal to x. And for the third piece of information, the number of cars is no more than 9. So x is no more than 9 means x is equal to 9 or x is less than 9. Part B. A car can carry 4 people and a minivan can carry 6 people. There are at most 60 persons to be taken on a tour. Show that 2x plus 3y is less than or equal to 30. Let's consider how many people can be carried about by cars. It will be x number of cars multiplied by 4, so that's 4x. And for the minivans, it will be 6y. So 4x plus 6y is equal to 60 or less than 60. Because at most, there are 60 persons to be taken. And if that's the case, we can divide throughout by 2 on both sides, left side and right side. So that will give us 2x plus 3y is less than or equal to 30. And we have completed the proof. Part C. On the grid, plot the 4 lines associated with the inequalities in A and B. Shade and label the region that satisfies all 4 inequalities R. So as we look at our graph, and our base from 0 to 15, our x cars, and our y-axis deals with our minivans. Our first inequality, x plus y is greater than or equal to 8. Let's rewrite that equation to make it look like a straight line by making y the subject of the formula. So y is greater than or equal to minus x plus 8. So that tells us that the graph is cutting at 8 and it has a negative gradient. And what do we also know? That when it's cutting at 8 and the y-axis on the x-axis is also cutting at 8. So we have our red line. And what does the graph tell us? The inequality is saying y is equal to that. So it's on the red line, or y is greater than that. So it's above the red line. And that'll be indicated by our red arrow showing any region above that line. The second inequality, y is less than or equal to x. So let's draw the line y is equal to x. A black line where we know when x is 0, y is 0. When x is 10, y is 10. And what do we know? Y is equal to x or y is less than x. So it means the region of the black line or anywhere below that line. Our third inequality, x is less than or equal to 9. So let's draw the line x equal to 9. And how do we do that? Our green line that we're bringing up, we're looking on the x-axis at the number 9 and drawing that line vertically upwards. And x is equal to 9 or less than 9 means it's going to the left of that. So any region to the left of the green line, inclusive of the green line. So we have 3 inequalities. Right now it's the red line, above that, below the black line, and to the left of the green line. And our fourth inequality, 2x plus 3y is less than or equal to 30. Let's rearrange it to make it look like a straight line as well, making y the subject of the formula. So let's carry 2x across. It will give us 3y is less than or equal to minus 2x plus 30. So if we want y alone, then we divide by 3. So y is less than or equal to minus 2/3 x plus 30 over 3 is 10. As such, we have a straight line graph cutting the y-axis at 10, and it has a negative gradient of minus 2/3. So when y is equal to 0, then x is equal to 15. Y is equal to minus 2/3 x plus 10. But if y is less than that, then it's anywhere below that line. So we now have all 4 inequalities. Above the red line, under the black line, below the purple line, to the left of the green line. So let's bring up that region in blue to indicate that that is the region R, which satisfies all 4 inequalities. May 2022, number 8D, Part 1. Determine the 2 combinations for the minimum number of cars and vans that can be used to carry exactly 60 people on the tour. So when we're considering looking at these types of questions, then the minimum and maximum points occur at the corners or vertices of the region R. At these vertices, the values are 8, 0 on the x-axis, 9, 0, 4, 4, as we go up with the intersection between the red and the black line, 9, 4, and 6, 6. As we're looking to get exactly 6 people, that combination was 4x plus 6y is equal to 60. Let's substitute the ordered pairs into this formula And we recognize that only at 9-4 and at 6-6, those combinations will we get exactly 60 people. Part 2, the company charges $75 to rent a car and $90 to rent a minivan. Show that the minimum rental cost for the store is $990. So if we're working out the cost at $75 for each car, that will be 75x plus 90y, as is $90 for each minivan. And if we want to get for exactly 60 people, we found in part 1 that there were only 2 ordered pairs, 9-4 and 6-6, which gave us exactly 60 people. So let's substitute that into our cost to see our totals. So the cost is 75 times 9 plus 90 times 4. In this combination, we're using 9 cars at $75 each and 4 minivans at $90 each, which works out to be $1,035. And similarly, if we substitute for the second ordered pair that solves the equation in part 1, then we have 6 cars at $75 plus 6 minivans at $90, which works out to be $990. As such, the minimum rental cost is $990. We've now come to the end of CSEC past paper questions in the topic of algebra, particularly the combined question of algebra and relations, functions, and graphs, which occurs in section 2 of paper 2. In our first video in this series, we looked at past paper questions from 2009 until 2013. Our next video looked at the following 5 years from 2014 to 2018. And in this present video, we've completed the past papers from 2019 until now. Don't forget to look at the description down below to get an overview of the entire CSEC Maths syllabus.